From a distance, it does not look that hard to get authorization right, but the devil is in the details. In this part, we take a look at one such detail, the use of insecure direct object references. So, what are direct object references and what makes them insecure? Let's take a look at an example. In our beer save application, we use direct object references to refer to tasting notes. Upon creation, every note is assigned a numerical identifier in the database. This identifier is used throughout the application to refer to this particular note. Here, you see how the identifier is part of the URL to display this particular tasting note. Here's a code snippet of how the backend handles these requests. As you can see, it uses the identifier to fetch the note from the database and returns that information. This looks pretty straightforward. But as you can see in the example here, the identifier of the note is 42. This makes it very likely that identifiers 1 to 41 exist as well. So what happens if the attacker modifies the parameter in the URL to fetch the other nodes? The application would simply return the data of the node. This vulnerability enables the attacker to retrieve all nodes in the application. This is a security problem, because some of the nodes are marked as private. Yet, all it takes to access them is having the right identifier. At this moment, you may be a bit surprised about the simplicity of the attack, but make no mistake, insecure direct object references are a real problem. They rank 4th in the OWASP top 10, and they do occur in real-life systems. Major websites and companies have suffered from such vulnerabilities in the past. The most obvious solution to this problem is to put proper authorization checks in place. In our beer save example, this comes down to the following checks. First, the application should check the visibility of the node. If the node is public, it can be returned. If not, then the application should check ownership of the node. If the user requesting the node is the owner of the node, access can be granted. In all other cases, access should be denied. Before we go on, let's summarize the problem. Insecure direct object references occur under two conditions. First, the direct reference to a server-side object is used in the requests. Second, the application lacks proper authorization checks on operations that use this identifier. The solution we have discussed before addresses the second part of the problem. By implementing proper authorization checks, the application can prevent unauthorized access. In some scenarios, a second mitigation strategy also works well. Instead of exposing direct object references to the client, you can use indirect object references. The server has a map that relates these indirect object references to their direct counterparts. Here is an example of how this would work. The user requests a list of nodes to view. The application fetches a list of nodes for the user from the database. It stores this list as an array in the user session. In the response page, the application refers to each node using its position in the array. These are the new indirect object references. When a request comes in, the application retrieves the list of nodes from the user session. Using the identifier, the application retrieves the right node from the list and performs the requested operation. Manipulating the identifier in a request will not expose tasting nodes. By design, an attacker can only gain access to nodes that are already in the list and are accessible anyway. This pattern works well because it makes the authorization more explicit. Compiling the list of nodes for a user will trigger the need for authorization. To conclude, this vulnerability looks surprisingly simple, but is often overlooked. Many applications using direct object references are vulnerable to this problem. Make sure that you implement the proper authorization checks on operations using direct object references. Alternatively, you can use indirect object references to sidestep the problem altogether.